Google Cloud Platform Overview Part 1. Now, this is an overview section. You can say it's like 10,000 feet overview of GCP. Google Cloud Platform is fastest growing public cloud platform services in the world now. They have recorded somewhere around 84% growth rate last year. They have committed many more data centers, many more POP locations. They are investing into the fiber optic cable, submarine cable, and that's how they are growing. As we know already, Google is prominent in data analytics, machine learning, and for so many years. Their services, which they are launching under Google Cloud Platform, is already proven for their own highly scalable, low latency requirements around the world. These services used by their well-known applications like, can you name it? Yes, YouTube, Google Search, Google Drive, Google Docs, App Engine, and so on and so forth. All of these applications require object storage, relational and NoSQL databases, analytics, machine learning, web and backend services with low latency requirements. All of these requirements met with their innovative solutions and its scalability across the globe. Now, all of that innovations in the infrastructure and platform, Google is offering to its enterprise customer in the form of Google Cloud Platform with relatively low cost. You can expect somewhere around 300 to 500% growth in upcoming years, which means considerable demand in GCP expertise. And when we say expertise, certification for that is Cloud Architect. And that's how it is becoming the best certification in the domain. This is Dhanaji. I will walk you through Google Cloud Platform. So if you are ready, let's go ahead and get started. When we look at Google Cloud Provider, we are going to just take understanding on Google data centers, POP locations, network backbone, regions, zones. What do we mean by those? What are services offered out of GCP? How you can access the Google Cloud Platform? All of those in this particular chapter. The first one is Google Data Center. Google data centers are unique in its kind and they carry some properties, and the properties are below in a high level. Renewable energy. Google Data Center has signed long-term contract with renewable energy producers where you can say they are investing a considerable amount of energy or money for future cleaner and greener energy. They are currently using somewhere around 37% of their operation using this renewable energy, and this will go high in subsequent years. Efficiency of data centers. Their data center operate 50% less energy than typical data centers. So what they do? They use outside air temperature to cool their data center. They higher the internal temperature up to 17 Fahrenheit. So that's how they are actually efficiently building their data centers. Custom servers. They are building their own servers for the data center. So it's not the heterogeneous servers. They are unified. They are building unified servers for their own data centers because they have knowledge, they have expertise in building those since so many years. Data and security. Right now, it's been a key for any cloud provider, and though it is physical data center security or data handling at the rest or in transit with the encryption, and that is key and which is provided by all the cloud providers, and Google is one of them. Just to give you a glance of what we had it on August 2017. So all of these blue boxes you can see, those were the proposed location for Google, and the green boxes were the existing locations for GCP. When we looked at here in this particular slide, it was updated in November 2017. You can already see that some of their commitment already fulfilled for the 2017. Example like Mumbai, Singapore, which were proposed as of August. You can see that has been fulfilled and is available for you to use it. With this, they have even planned like Los Angeles as an additional data center, Montreal, Netherlands. So these were not there earlier. These are like, you can think of it's like new data center or locations which they are proposing or planning to have it. GCP point of presence. GCP has point of presence or edge location across the globe. These edge locations are connected by the fiber optic network, which is owned by either Google or it's in partnership with the Google, like the green ones, where they have invested in these cables. But this is how they are providing low latency network across the globe. Someone estimated, I don't know exact company, but they estimated that there are around 40% traffic which is handled by this fiber optic network across the globe. So all internet traffic, out of which 40% is traffic carried over by this fiber optic network. So why someone will use these pop locations, or how this will be used for real customers? So you can actually think of one case wherein if there are customers which are located in, say, South Africa or any South African countries, they want to access your service which are available in say London, right? If you have hosted service there in London or in Europe, what will happen is, if they are accessing, say as an example, you have example.com service, typically what will happen is, if you have hosted that in any other provider, it will be routed via public internet up to that particular region or the location, and then it will get into a service. But in case of Google, what will happen is, it will routed, your traffic will be routed to nearest pop location, which is Johannesburg, and then via private cable or private network, it will go to your service. And that's how the pop location will help you as in customer or your customer to have low latency application accessed across the globe. There are some pop locations which are, or you can use it for CDN, and if you understand CDN, that's where you cache your static content for your website. GCP regions and zones. So you can think of these locations available for you to use in many locations. These regions are divided into, so all of these locations you can think of, or you can map it to US regions, but they have a different system name altogether, and we'll see that later, that in here. But what it is, regions are independent geographic area that consist of zones. The main purpose for these regions are, you can actually host your application near to your customer. If you are if your customer base is in Asia, then you don't want to host your application that in US location, because the latency will be higher. So what you do is, you host your application in your Asian region. That's how regions are used. The zones are typically the location or physical separation within or inside the regions. So these are typically used for your high availability requirement. As an example, you have Asia East 1 as a region, and you have multiple zones, and you want to have high availability for your applications. As an example, website, what you do is, you host your application in both the zones in Asia. That's how, even if one zone is not available, your application is available from other zone. This is an example you can think of. I have taken it some time back. US Central 1 is the system name for this one, and this is the region, and in that particular region you have A, B, C and F. These are the zones, and likewise you have in Europe, you have in Asia, you have in Australia. GCP resources, because of the way any cloud platform is divided into region or zones, the resources within the cloud platform is also divided into those categories. So there are some resources which are global, those are available or accessible across the globe. You can think of disk images, snapshot, or virtual network. All of this is the global in its nature, and those are global resources. Regional resources, only accessible within the region. You can think of the static IP address, but these regional resources accessible in multiple zones within the region. And there are some zonal resource, and you can think of these are the physical things which you are using in a particular zone. As an example, your virtual machine instances or disk images, etc., etc. GCP services. So you have solution for all your need. You starting from your infrastructure as a service, platform as a service, or software as a service. You have all of that is available in GCP. But definitely software as a service for some domain and not for all domains. You can think of if you want to take your existing data center onto cloud without modifying any applications, you just want to have box of machines and you want to install your own software, you can just go ahead and use infrastructure as a service like CPU, memory, disk, and all other network interfaces. And you manage you don't have to manage the hardware, so that's the only thing which you don't manage. You manage health of your application, health of your operating system, and all of that, because you are using software as a service. You manage your backup, you manage your replacement of anything, right? Any software component. Whereas in platform as a service, you manage your cluster. As an example, container management system or orchestration system, Kubernetes. You just provision it and use it, and all of that auto scaling and everything will work for you without you worrying about the infrastructure provisioning for it. In case of software as a service, you just want to use the service, right? You don't want to manage anything else besides the service, and that's where App Engine provides. You just deploy the code, and once you deploy the code, it will scale automatically. It will configure high availability automatically. You don't have to worry about anything. Or you have some software as a service options. You can use identity, resource management, you can monitor the services, all of that you have available, and you can use it as a software as a service. So in nutshell, it is divided into multiple groups, these services. One is compute service. You can think of virtual machine, which is compute engine, app engine. Container engine is Kubernetes in GCP. And you have additional or supporting services like container registry and cloud functions as a part of compute service. You have networking service, which is like cloud virtual network, or you can think of VPC. You can isolate your own network within your GCP. That's where you configure it using cloud virtual network. You can utilize global load balancer or internal load balancer, cloud CDN, cloud interconnect, and DNS. So interconnect is where you you want to connect from your infrastructure to GCP. That's where you use interconnect. Then you have storage and database services. In that, you have Cloud Spanner as a horizontally scalable relational database. You have object storage as a cloud storage. Bigtable, you can think of HBase implementation inside GCP, but it is fully managed. Cloud Data Store, you can think of it's a document, NoSQL document database in GCP. You have Cloud SQL, which is MySQL and PostgreSQL in GCP. And you have Persistent Disk, which is like network attached storage NAS in GCP. Then you have identity and security. You can manage user roles, permissions using Cloud IAM. You can have Cloud Resource Manager, Cloud Security Scanner, Cloud Platform Security as an additional supporting component for your security. You have big data services from GCP, which is BigQuery, which is data warehouse in cloud. Cloud Data Flow, which is ETL jobs. It's an Apache Bean implementation. We'll look at that in their respective chapters, but it is ETL and Apache Bean implementation in cloud. You have Dataproc, which is Hadoop and Spark cluster in GCP. You have database, Data Lab, which is actually visualization tool into GCP. You have Cloud PubSub for messaging. You have Genomics for genomics purpose. Then you have a machine learning service from GCP. That is Cloud Machine Learning, which is TensorFlow implementation inside. GCP, and then all other APIs like vision, speech, natural language translation APIs. All of those are APIs which you can use it from the machine learning service. Besides those main services, you have supporting service like management tools and developer tools. In management tool, you have Stackdriver options. So Stackdriver is a company which they have taken over some time back, and they were providing services like monitoring, logging, and they have a now they are offering this service as a managed service into GCP. So you can monitor your resources, you can use logging from Stackdriver. Additionally, for App Engine and some other services, you can do error reporting, trace, and debugger. That's a part of Stackdriver offerings. You can use deployment manager for your like shape perfect requirements, automatic deployment, continuous deployment. Cloud Console, Cloud Shell, Cloud Mobile App, or you can think of is the interface for you to interact with Google. And then there is a billing app. For developers tool, you have Cloud SDK. Again, it's as a part of interacting with GCP, you can use SDK, and you can use gcloud commands to interact with Google Cloud. Deployment manager, again I said it's an shape perfect like tool wherein you can create a template and create a deployment script. You have Cloud Repository. It's like a Git in your GCP. And then you have multiple SDK supporting your Android Studio, IntelliJ, PowerShell, Visual Studio, Eclipse, like that. And then you have a Cloud Test Lab. In November 27, they have positioned another software component called Apigee. They have taken over this particular company some time back, and they are using API management from that particular software. So you have API management, API monetization, API analytics, and Apigee Sense from Apigee suite of applications. Originally, they had Cloud Endpoint as their own core API management software, which you can again you can go ahead and use that as well. On top of it, they have a transfer service. So consider if you have hundreds of terabytes of data which you want to take it to Google Cloud, rather than waiting for data to be uploaded to the cloud, what you can do is you can use transfer appliances. These are the physical devices, and you can map this to Amazon Snowmobile service, right? So you will get the device, you can transfer the data into the device, and then you can ship it to them, and then they will load that into a data center. Or you can use cloud storage transfer service. As an example, if you have a data available there in AWS, which is like another cloud provider, you can create transfer jobs, and it is a batch job. It will be done without you actually staring at your screen in the Cloud Console. So you can create these jobs, and it will take care. And then you can have a BigQuery data transfer service as well. That's all about the cloud platform as an overview, part 1. We'll get into part 2 in next chapter.